Okay, so from this point onwards, I want to highlight some of the things that are really important in the key reading that you have for this week. So it's basically a chapter from Francesca Lagioia, I think, and Giovanni Sato. And the chapter is called Artificial Intelligence in the Big Data Era, Risks and Opportunities. And unsurprisingly, I'm asking you to really focus in on the risks and opportunities. But in doing so, I'm hoping that you will get a better understanding of how AI works, especially for those of you who, and there will be many of you who are unfamiliar. And with a view to getting some foundations that mean that next week we can launch into looking at the legal considerations. So until a few decades ago, it was generally assumed that humans had to provide a formal representation of the relevant knowledge that they have, so rules or concepts, decision trees, that kind of thing, and put some algorithms with it in order to make inferences out of the knowledge and effectively program a machine. But what we've actually seen is that as we've got more and more powerful machines, with different approaches to developing machine learning, particularly neural networks, we're seeing a significant change in the kinds of artificial intelligence that is possible. So a really important term here is machine learning. So machine learning effectively is the process under which a computer system learns how to make accurate predictions when it receives data. It uses pattern recognition so that machines can observe and learn for themselves, and it enables computers to tackle tasks that previously only people can do. Remember Kurzweil's definition? So whether that's driving a car to translating speech, or diagnosing a cancer, machine learning is driving an explosion in AI capabilities. So take a look at this chapter, and I'm going to identify some of the things that might be a little bit trickier to understand in advance, so we can have a really robust conversation about this chapter in our class on Wednesday. So a key thing that you need to understand about AI, or artificial intelligence, is not all AI is the same, and we generally, in the research that you will be reading anyway, we distinguish between two goals. Artificial general intelligence, so this is often referred to as strong AI, or artificial specialized intelligence, or weak AI. Artificial general intelligence pursues the ambitious objective of developing computer systems that exhibit most human-like cognitive skills, and whether that's at a human or even a superhuman level. It is this strong AI that is aiming to meet the Turing standard or the Kurzweil standard. On the other hand, artificial specialized intelligence, or weak AI, pursues a more modest objective. What it's trying to do is develop a system or a process for addressing a single important area at a satisfactory level, so to engage in specific tasks that require intelligence. In the reading that you have, the authors talk about the development of computer systems that exhibit the most human cognitive skills, and refer to that as artificial general intelligence, or AGI is the acronym they use in their paper. And they refer to artificial specialized intelligence, or weak AI, as ASI, and again refers to that as a modest objective. I think I might have borrowed their words when I was talking about it a bit earlier. General AI systems improve themselves at exponential speed, and they quickly can become superhuman. Humanity itself could find itself in a condition of inferiority similar to that of animals in relation to humans now. Sometimes this is referred to as the singularity. Some leading scientists, and the paper talks about this, have looked favourably on the birth of an intelligence that is meant to exceed human capabilities. The risk related to the emergence of this kind of intelligence shouldn't be underestimated because they will pose challenges in the future. However, because artificial specialized intelligence is already with us and it's transforming economic, political, social arrangements, it's changing the ways that we interact with each other as individuals, the way that we interact in our private lives, with our banks, with our employers. All of these things, we've begun to start to think about these legal considerations. Legal issues with AI, the authors point out, have already emerged in a large number of domains. These can range from things like civil liberty, insurance, data protection, safety, contract, even crime. One of the things that's really interesting about strong AI and the interest or the move towards a general AI is the inclusion of a much more interdisciplinary effort amongst researchers and the developers of these kind of systems. In the paper, you'll read about a number of initiatives that have been undertaken to design an ethical and legal framework for human-centered AI, but it's still early days. It remains to be seen whether these initiatives are going to prevail over the economic, political, and military purposes that we have for AI. So let's keep going for a second and let's just make sure when I think about weak AI or specialized AI, I think about expert systems. And particularly because I've spent most of my adult life as a lawyer, much of the talk in the legal profession about the ways that we can use artificial intelligence is as expert systems, as decision-making systems of some sort. So expert systems, and these include vast domain-specific knowledge bases that are coupled with inferential engines, have so far not been terribly successful. Or if they have been successful, that success has been pretty limited because they were really only able to provide incomplete answers, and they were often unable to address the peculiarities of individual cases, and they required persistent and costly efforts to continue to broaden and to change their knowledge bases. More recently, artificial intelligence has made some really impressive leaps forward. And since developers of artificial intelligence systems have begun focusing more on machine learning rather than decision trees or expert analysis, we've seen substantial economic and social impacts from these kind of systems. Machine learning approaches use these learning methods to help machines learn how to effectively accomplish their tasks by extracting relevant information from the data that they receive. So all eyes are on machine learning. Now, machine learning itself is an umbrella term. It's really just a cluster of technologies, all of which use algorithms to improve predictions based on continuous ingestion of data. Machine learning is a powerful tool that can achieve its goals in ways that are not always anticipated by its creators and its trainers. I'll talk a little bit about training in a minute. Explicit logical modeling of knowledge and reasoning, so expert system approaches, can be complementary to machine learning, and it may be that it is too soon to throw that baby out with the bathwater. According to the authors for the reading you have this week, supervised learning is currently the most popular approach when it comes to machine learning, and I will chat about the different types of machine learning in just a minute. So a supervised learning approach is where the machine learns through supervision or through teaching. So it has a trainer. In many cases, a training set doesn't require human teachers, though. It doesn't require them to provide the correct answers, but this can be obtained as a side effect for the other activities that the system goes through. Now remember, we need to be very careful when we're dealing with AI to be certain that we are actually dealing with something that is making its own decisions, or whether it's replicating or imitating a human. I mentioned Goosterman before. I knew I'd have a slide on him somewhere. Goosterman back in 2014 was a winning chatbot in a Turing competition, a Turing test competition. Eugene Gooseman was the name of the chatbot. It claimed to be a 13-year-old Ukrainian boy, and it convinced in the order of 33% of the judging panel that he was a human. The factors that assisted Gooseman, including English, the language that the test was held in, not being its first language, it's his, I'm not sure what pronoun to use, his apparent immaturity and the kind of answers that he gave that were designed to use humour to deflect the attention of the questioner from the accuracy of the response. It was not hailed as being a great advance in computing, and I have added a New Scientist article about the test and about Gooseman into your reading, because I think it's just always worthwhile thinking about that historical foundation, because we don't always, when we're interacting with an intelligent machine, know whether we're acting with general or specialised intelligence. So quite a bit of criticism, but interesting. Again, Jacob Turner's book deals with Gooseman in a very interesting way, worth having a look. So while I mentioned that supervised learning is probably the most popular, according to the authors of the chapter you're reading anyway, at the moment, could be something different by the time we actually release this video. There are other really important ways that machines learn, and I just wanted to highlight some of them to you, and they are mentioned in the article. The authors introduced the idea of reinforcement learning, where a system learns from the outcome of its own action, basically through the rewards or the penalties, so points that it gains or loses that are linked to the outcome of the actions that it takes. In unsupervised learning, a system learns without receiving external input. Reinforcement learning is machine learning training method that's based on rewarding desired behaviours or punishing undesired ones. Frankly, sounds like training a puppy, only possibly not quite as cute. In general, a reinforcing learning agent is able to perceive and interpret the environment, take actions, and learn through trial and error. Reinforcement learning models aren't really great for solving simple problems. They usually are more useful where we've got really complex problems that require a lot of training data. Basically, they just cost too much to run. They require so much data that the effort for reward ratio just isn't there at the moment. There's just so much maintenance on both the hardware and the software. But they are used, reinforcement models are used regularly in ways that most people probably aren't necessarily expecting. They're used in learning, business, marketing, advertising, in all these money-oriented fields, really. Reinforcement learning models that companies have can analyse customer preferences and help in better advertisement of the products. It reacts to what you swipe past and what you look at, and then tries to predict, that word again, what kind of behaviours are going to attract that elusive copy and paste in of your credit card details. One of the prime usages for reinforcement learning is in gaming, online gaming. So there are platforms that focus on providing better game environments by modifying the emulators, and they use deep learning algorithms. And then, of course, there's AlphaGo, AlphaZero, tools like that. Clearly, a very popular use of reinforcement learning algorithms is in recommendation systems, Spotify being my personal favourite. Reinforcement learning is a really big help in recommendation systems that are not limited to things like Spotify and Netflix. Somewhat scarily, it's also the news that you get. The information that you're exposed to may well be influenced by a reinforcement learning algorithms. The apps work as customer preferences are really cloud-based these days. Reinforcement learning in science, I think, is really interesting. So artificial intelligence and these reinforcement learning models are becoming a really important part of the research that's being done in atomic science and in chemical properties. Deep reinforcement learning can help us understand chemical reactions and yield significantly better products because that ability to process and recognize the patterns is so much quicker than the poor old human. Now, if we're going to have supervised learning, which I mentioned earlier, clearly there must be the opposite, unsupervised learning. These tend to be used for clustering, so putting items into groups in order to find relevant similarities or connections. It's a learning methodology in machine learning where the model learns through training itself from the data. On the slide, you can see a clustering algorithm that classifies data of apples and watermelons. They're all mixed together. Unsupervised learning solves the problem of labeling data by learning the data and classifying it without any labels. So it can be useful in eliminating bias, something we'll talk about a little bit later. And it's very helpful in finding patterns in data, and dimensionality reduction can be easily accomplished using this kind of approach. Disadvantages? It's learning from raw data without any prior knowledge, and so it takes a lot of time to calculate all possibilities. Of course, Moore's law means that time can be expected to radically shorten. And then back to where we started with this idea of supervised learning, the current most popular approach, where effectively there is training, but the training algorithms may in fact be algorithms. They may not necessarily be humans. And so take that into account as you think it through. And then we end up with this concept of a neural network. So deep learning is essentially a subfield of machine learning, and deep learning uses algorithms that are inspired by the structure and the function of our brains. It's the key technology behind things like driverless cars, voice control in consumer devices, and other functionality that we see machines having that required, as Kurzweil would have called it, the intelligence of humans to adopt. Of course, to do this, deep learning requires large amounts of labeled data and substantial computing power. High-performance GPUs can reduce the training time for deep learning networks. So how does it work? Most deep learning methods use neural network architecture, and deep neural networks can have as many as 150 hidden layers. Deep learning models are trained using enormous data sets, and that data needs to be labeled. So they use a thing called CNNs, not the news broadcaster, but convolutional neural networks. So these are, well, not all of them do, but these are one of the most popular types of deep neural networks because they eliminate the need for manual feature extraction. They're highly accurate for computer vision tasks, for example, classifying objects. CNNs use tens or even hundreds of hidden layers to detect different features in an image. So what's the difference between machine learning and deep learning? Deep learning is a specialized form of machine learning. So all deep learning is machine learning, but not all machine learning is deep learning. It automatically extracts relevant features from images, and it creates a model that will categorize the objects in the image. Remember though, it is absolutely dependent on labeled data in, and some of the additional videos that are on the platform start to explore bias, particularly in these kind of recognition algorithms. The inability, for example, of many facial recognition algorithms to identify black women in particular. I have a funny story there actually. I've been working in this field for a very long time, and in the 1990s, yes, that's how long ago, I was doing a lot of work with a facial recognition technology provider. I thought I was going to be so rich. That's a terrible thing to say, but when 9/11 happened and we had this technology that could tell the difference between a human face and a photograph of a face in an image, we thought the security would, the uses of this would be absolutely phenomenal, and we were all going to be super wealthy. Little did we know, if we'd been putting more of our effort into getting your camera to recognize a face and focus on it, we really would have made a lot of money. We just kind of had the wrong application and wrong market. But anyway, let me tell you the story that I was aiming to tell you. I think might have been early 2000, 2001. I must admit I was going through a bit of a low patch in my life. I had 2 kids. I was feeling I was still in my 30s, but I sort of felt like life had passed me by a little bit. And anyway, I went to the launch for some investors of this technology. And they had it all set up, and it was recognizing people's faces left, right, and center. And so, people were saying with a photograph next to it and a doll and whatever, and it would be able to recognize the face. I know everybody's camera can do that these days. Doesn't sound like a big deal. But in 2001, 2002, it really was a big deal. But try as I might, every time I got in front of that camera, it just couldn't see me. It just could not see me. The technology it worked. No, if there were 100% of 100 people in the room, it worked on 99 of them. It just didn't work on me. It was some years later that I clicked. I'm embarrassed about this, but it was some years later that I clicked. I was the only woman in the room. And that's why it didn't think my face was a face, because the data that it had been trained on was data, basically the images of the engineers and the software developers, who on the whole were either Asian or European men. And so even though I've got a fairly European look, my face didn't have the deep parameters that these kind of networks look for. So yeah, we don't even realize it. I didn't think of it as bias at the time, but basically the data that was used didn't actually train it in a way that meant it recognized me. So I think it's worth just having a look. There's a lot of stuff about facial recognition, but also the way that AI can develop faces now that look human. Deep Face is a tool that uses deep learning algorithms, which basically will help scan. You can use it to scan images and then animate it, for example. These kind of tools use up to, Deep Face uses 68 landmarks, so specific points on the face, and the differences and the geometry of them in order to tell the differences. It basically maps the image and encodes the image, searching for matching stored data, essentially to identify people. This is being used by your bank. So Westbank is one of the companies in Australia that's exploring the use of AI-enabled facial recognition to monitor the moods of its employees. Mood. Not just where are my employees, has the right person come into the building, but are they acting in a way that we think is appropriate? Reps at Westpac have indicated that the goal is to take the pulse of teams across the organisation. Feels a bit creepy to me. I wonder, is it going there to benefit employees, or is it there to maximise profit in some way? I've used this word prediction over and over again, and I want to come back to it. In a machine learning sense, we talk about prediction to mean the output of an algorithm after it's been trained on a data set and applied to new data when forecasting the likelihood of a particular outcome. For example, will this customer like this particular book or this particular piece of music? Or what is the likelihood that in the next 30 days they're going to drop their subscription? To predict a certain outcome in a new case, you need to jump from certain known features of that case to unknown features. That's what we do every time we try and guess what the future might be like. So machine learning does that by using models that capture general aspects of the context that's being considered. And the connection that exists between the AI applications and the processing of the personal data is something that we're going to continue to explore. So predictive data is used for a range of different things. By looking essentially at or looking for patterns, companies are predicting whether somebody is going to be creditworthy or not, whether they're going to be a good parent or not, whether or not they might have a medical condition based on the past patient's characteristics and medical tests. AI systems that are based on machine learning use these massive data sets, the big data we spoke about last week, and these can be collected by pretty much any kind of information communication technology. The data is produced across all domains where computing is deployed, including economic transactions, surveillance devices, and non-market activities. So in recent years, the internet has become this kind of global, interconnected, data-producing, data processing infrastructure, which allows a person to shop, use banking, watch porn, play games, pay their taxes, get government benefits, go to university. All of these seemingly disconnected pieces of information can, theoretically at least, be connected, and we can learn things about people and predict, based on the patterns we recognize, what might happen next. AI uses all kinds of personal data to analyze, forecast, and influence human behavior. So the data itself becomes a valuable commodity. The other thing I want to mention here is the infrastructure that connects this data. It can deliver a whole lot of benefits, including better access to information, generation and distribution of knowledge across the world. It can save cost, it can improve productivity, it can create value, and many new jobs which will be creative and challenging and interesting are going to arise as people try to tackle this technology. But of course, as the authors point out, there'll be many old jobs that, particularly those jobs that don't require creativity or the asking of questions, but just the production of information or the recognition of patterns or the finding of the answer to the question asked. These are very likely to be replaced by these technologies moving forward. With prediction, I think it's really interesting too, because one of the things that we see happening a lot is predictive technologies being used as a new diagnostic tool in medical circumstances. There's some really interesting reflections on this, and Malcolm Gladwell in particular, an author journalist that I find particularly great writer, writes really eloquently about the way that an expert might see, 1,000 cases in a year, and of those, so I'm talking about a medical, say a cancer expert, they might see 1,000 cases in a year, and of those, if their patients are really unlucky, maybe 20% actually have a serious condition, and of those 20%, there's probably, they might get one a year of a particular type. But one of the things that we can do, in your lifetime as a professional, as a cancer specialist, is probably somewhere between 30 and 40 years, generously. I don't know. I've been a lawyer for 30 years. I'm finding that as a specialist, I'm less and less anxious to spend my time doing it. But that's a story for another day. What is really interesting here is that while a machine can learn, once it has learned, it can transfer all of its knowledge to another machine immediately. The learning doesn't have to happen every generation. Like, your mum learned something at school, and then you were born, and then you had to learn it too. And bits of it that stuck for your mum might not have stuck for you, and vice versa. When a machine learns something, the thing that it learns, it can be transferred, but it won't necessarily be transferred in a way that a human can understand. So think about that incredible computing power, the ability to look at thousands and thousands of examples and learn from those in a way that a specialist might in their lifetime only see hundreds of examples. Provides for that enormous computing power that we see. And one of the reasons why esteemed journals like Nature are reporting on ways that deep learning can be used to really understand better how drugs or gene variants can affect the spread of tumors in the body, and looking at ways that microscopes, for example, can be trained to spot the nuclei, the most important element. Okay, I think that's enough for this video. It's gone on for a little while. I think we'll come back and start talking about when machines need to make complex choices and dig a little bit deeper into this issue of bias that is so much a focus of the reading that you have, looking at the risks and the opportunities. So I'll see you in the next video. Cheers.